Hi, this is the write-up for Freeze Challenge from RITSEC 2018 CTF. For this challenge we were given two files, an elf file and a library. So let's just try to run the binary. It just prints the timestamp. So let's try to get some more introspection into what the binary is doing. So some early initialization. And here we can see that some stuff is going on relative to Python libraries. So maybe the challenge is written in Python. In some way it is embedded inside the binary and it is loaded at a runtime. Let's try to trace the library codes. So here an environment variable is red. Maybe it will be useful, maybe not. Here a string with this library is written in memory, and then we can see that some functions are called using the dynamic resolver, and they do some initialization. The name of the program is set. Here we can see that something interesting may be going on. Some code is evaluated, and here we can see that some unmarshalling is going on. So probably some Python objects are marshaled inside the binary, and these objects are loaded in the memory. So we can try to dump this memory let me show you the documentation for this function. The first parameter is the stream of data, and then simply the size. Since we are on x64, we're gonna have this parameter into RDI and this one in RSI. So we can just do dump memory into dump1 RDI plus. Then we can continue, and we hit again this function, so we do another dump. Okay, let's continue, and it's finished. So now we can inspect our dumps. Since we know that these data are marshaled, we can simply use Python to unmarshal the data to see what's inside. we have two code objects. We can inspect them using this module. So we can disassemble the first one. Here is the environment variable we saw before. This code apparently just do like initialization and this kind of stuff, but there is no important logic for us inside this code. So let's have a look to the other one. This looks more promising. We have a string which gets stored in this variable, which could be the flag encrypted in some way. And we saw that the binary simply outputs the timestamp, so this looks meaningful. Then two functions are created, A and B, and A is called. Then the current data is stored as a string, so the timestamp is stored in a variable. And then we have a call to the function. Let's just try to eval the code blindly to see what happens. It behaves exactly like our binary. So now that we executed this code, we have in memory the two functions that are defined inside it, so we can inspect them again using this. A function, in this first part, a date time is created and the value is hard-coded. Then the current time is saved as a timestamp, and the comparison happens. Depending on this comparison, we can reach this path, which prints the string happy birthday, here is your flag, and which is this date, of course. And then the function B is called with the time and the encrypted string we saw before as parameters. So this is the decryption function, essentially. We can try to run it, and indeed it takes two arguments. To call this function and get the flag, we first need the timestamp of our magic date. So this should be our magic value. And the flag is broken. I think that maybe this could be due to some time zone issues. Anyway, we can just brute force this function with the values of the time range that we are interested in. Since this function, as you can see, directly prints to standard output, and we wanna do some kind of filtering on the results, I will just override the standard output to a file. Now let's write the loop to brute force. Let's try to use a step of half an hour. So we have our log with the possible flags. Let's check it. So let's see if we can find some meaningful flag. And here it is, the flag.